Okay, most of the students had an issue with learning how to deal with the left recursion and left factoring. So I just wanted to explain them with left recursion and left factoring, and we shall look into those. Okay, a small explanation here is a grammar will be either an ambiguous grammar, or an ambiguous grammar, right? So for ambiguous grammar, we should make it as a unambiguous grammar. Ambiguous grammar has much problem because it is having more than one leftmost derivation, and it will be having more than one rightmost derivation, and both the parse tree will be looking into the same. We need to avoid this particular cases. So how do we make a grammar unambiguous is we need to eliminate left recursion and left factoring. So how do we eliminate the left recursion? In order to eliminate the left recursion, we have to bring the particular grammar into a form, right? A grammar will be in a form of A tending to A alpha 1, A alpha 2, A alpha 3, and it moves on. How do you know that this grammar is left recursion? Whenever you have A, that is my left hand side as well as with the right hand side of a production will be the same. So we don't want that to happen. If both left hand side as well as the right hand side, if both are same, then we can say that we have a issue of left recursion and we need to solve it out. So the thing is, we need to eliminate that. I don't want any production where the left hand side as well as the right hand side will not be repeated. So I need to avoid that particular state. We don't want that to happen. So one way is, how do we try to eliminate it? So we try to eliminate by using the form where I had A is tending to A alpha 1, I have to replace with A is tending to beta A dash. So A is tending to beta A dash. So what is beta? Beta is a production where I don't have the symbol of start symbol in the beginning. That becomes my beta. So A is tending to beta A dash, and A dash is tending to whatever I have left off. I have alpha 1, I have alpha 2, I have alpha 3. So A dash is tending to alpha 1 A dash, alpha 2 A dash, and A dash can also be a epsilon. So this is my grammar which is free from left recursion. So looking into the algorithm here, the algorithm for left recursion looks in this way. Grammar G with no cycles of epsilon production. I should not have any epsilon production within this particular grammar which I take. If you have an epsilon production, then it will be a problem. So my grammar or the input grammar should be free from epsilon. So once it is free from epsilon, the output which I can consider is, my output will be no left recursion grammar. So what is the steps which I need to follow is, arrange the non-terminals in some order, that is A1, A2 up till AN. So this is about the A1, A2 until AN. For each I from 1 to n, and for each j from 1 to I minus 1. Replace each production of the form AI to AJ gamma by the production AI tending to delta 1 gamma, delta 2 gamma, because gamma and gamma are further repeating. Delta 1 is different from delta 2, right? So where AJ is tending to, that is AJ is tending to delta 1 or delta 2 until delta k, or all the concurrent AJ production. eliminate the immediate left recursion among the AI production. So we'll look into the one or two examples which gives you easy understanding over the eliminating of left recursion. As I said, the grammar should be having the same symbol left as well as on the right. So here I have E, which is a production which I have on the left as well as on the right. So what is that we need to work on here? I should not have the repeating things. So this is of the form E is tending to A alpha or beta, E is tending to alpha 1 A dash. So here let me write here. So A is tending to beta A dash, and what does A dash say? A dash is tending to whatever I have with alpha A dash or epsilon. This is my ground rule. So always understand the ground rule clearly, so that if you follow this particular value, you will be easily understand how exactly it is working, right? So here you can see this is A. So what is A? E, right? So what is A dash in our case? E dash, right? So E is tending to E plus T, and what is alpha here? Plus T is my alpha. So E is tending to T E dash, and that is E is tending to alpha E dash, beta A dash. Alright. So the next case is E is tending to alpha E dash, and E dash is tending to E is tending to beta E dash, and E dash is tending to alpha E dash. So what is alpha? Plus T, and plus T E dash, and followed by epsilon. So another case is, we'll look into another example. T is tending to T star F or F. So it is of the form where T and T are repeating. So T is tending to Ft dash. So what is F here? Basically it is beta. As I said, A is tending to beta A dash. So beta T dash, and T dash should be alpha, that is star F or epsilon. Third case is S is tending to S within brackets SS. So here what is the term which is repeating? S is repeating. So I have term S. S is tending to beta. What is beta? Beta is epsilon. So I ignore it, right? Even though I epsilon doesn't make any sense. So S dash. So what is S dash? S dash is tending to what is alpha? Open S, close, and S, right? So open bracket S, close, and S. What is my A dash or S dash, and followed by epsilon. So this is my grammar which is free from the left recursion. Next case is looking into another example. What is the term which is repeating? S, and here SS is repeating, here also SS is repeating. So S and S is what the state which is repeating. So what is beta? A. So according to the term, what is my value which I look for? A is tending to beta A dash. So what is beta? Beta is small a. So my production should have A is tending to small a dash. A dash, sorry, S is what the term which I am looking for. So this is S. S is tending to A, S dash, and S dash is tending to what is my alpha? My alpha is S plus. So S plus S dash. Similarly, alpha 2 is S star, and ultimately epsilon. So these are my grammar which is free from left recursion. So ultimately, as you can see here, I have E and E which is repeating. So this is my alpha and this is my beta. Alright. So E is tending to beta E dash. So what is beta? T. Fine. So next thing is E dash is tending to alpha, that is plus t, E dash or epsilon. This is for the first case. Second, is this both repeating? Yes. So t is tending to f t dash. So t is tending to f t dash, followed by I have to work for t dash. So t dash is tending to star f t dash. T dash is tending to star f t dash or epsilon. So these two productions are for this particular production. And ultimately, do I have left recursion here? No. So there is no left recursion required for this example. Similarly, working out with the left factoring, A is tending to, this is the case, when do I say that it's a left factored grammar? I have a same symbol which is repeating. So I should not have that particular grammar which will be repeating on the right hand side. So how do I eliminate with that particular case? So it is easy. So A is tending to alpha, that means right hand side I have my terms repeating. I should not have this also, right? So A is tending to alpha b1, beta 1, alpha beta 2 or alpha beta 3. If this is the case, I don't want this to be starting with the same iterations or same grammar, right? So A is tending to whatever is repeating, I make it as only one term, that is alpha followed by A dash, and whichever the term which doesn't have this will become my gamma. So A dash will be tending to beta 1 or beta 2 until beta n. So the grammar for the left factoring looks in this way. Algorithm left factoring grammar G, an equivalent left factored grammar method. For each non-terminal A, find the longest prefix alpha common to two or more of its alternative. If alpha is not equal to epsilon, that is there is a non-trivial common prefix, replace all of the A productions, that is replace this with respect to this and this. If you look into one term or an example here, we'll try to understand it. So here A dash is a non-terminal repeatedly. So we'll look into one example here. Yeah, this is one example where what is the term which is repeating here. So on the right hand side, I have two double S's which is repeating on the right hand side. So there is a grammar which needs to be left factored, right? So as I said, this is of the form A is tending to alpha beta 1 or alpha beta 2 or gamma. So if that is the case, A is tending to alpha S dash or A dash or gamma, followed by S dash is tending to beta 1 or beta 2. So S is tending to, what is alpha? Alpha is S and S dash followed by A. And what is S dash? S dash is tending to beta 1, that is plus or star. So what did we do? These are my left factored grammar where my grammar is not starting with the same symbol on right hand side of each production. So the common terminals we have to take as alpha, and the remaining term we have to take it as beta 1, beta 2 and so on with respect to each production. So this is one example. We look into the second example so that it gives us the clarity. So S is tending to 0 S1. So what is the term which is repeating here? Just O or 0, right? So according to the syntax here, so A should be tending to alpha A dash, and what is my A dash tends to? A dash should be tending to my beta 1, beta 2 and it goes on, right? So what is A? A is S. So S is tending to, what is alpha? Alpha is 0 because it is repeating. So 0, what is A dash? S dash. And the other thing is, so what do we have here? Of course, alpha is again with the same, what is, so epsilon is the term which we use because it can be the case. So next is S dash, in other words A dash. A dash is tending to what? Beta 1, beta 2. What is beta 1? S1. And what is beta 2? 1. So S dash is tending to, what is beta 1? Yes, 1. And what is beta 2? Just 1. So these are the grammars which are free from left factoring, as we all know with the particular case. So this is about the thing which students had some problem with. So if there are any other questions which you have, kindly let me know in the chat section so that we'll work on it. I think these are the two terms which a student which actually asked me for, and it will be there in the YouTube, so that if there are any questions with anyone, can look into it at any time. And let me know in the comment section if you have any issues or any queries. And all the best for your tomorrow IA, and work out with it. Thank you, class.